Hello, Jonas, and welcome to Func
Hello.
Sweden.
Yes.
Yes.
So thank you. I'm really happy to be here, and thank you, Magnus and Ada Beat for organizing this wonderful meetup. Let me share my screen. I have some slides. Go. Right. Can everybody see my slides? I hope so. Yeah. So I'm Jonas Juselius. I'm the CTO and co-founder of a startup called Oceanbox. I'll get back to a little bit, tell what Oceanbox is doing, but first I'll say a few things about myself and functional programming. So I'm not a computer scientist. I'm actually a chemist by training, but I've been programming for nearly 40 years. And past 13 years I've been doing functional programming, and the past 10 years I've been doing F# professionally. I've also been teaching at the university at the computer science department, functional programming in F#. And during the pandemic, I recorded everything. I put it on YouTube, and some people seem to like those videos, so you can find them there if you're interested. My students don't like them for some reason. So I thought I'd say a few words about functional programming for the benefit of if there's any sort of newbie functional programming programmer here. Well, I was thinking back and thinking of how was it to learn to do functional programming, and I found it quite difficult in the beginning. I had to think very different in a different way, but just hang in there. Functional programming, once you get used to it, is just normal programming, only slightly less painful. So don't panic, stick with it. You'll be fine, and you're gonna have a much better time developing software going functional, I promise. The other thing, this talk is not going to be very heavy on either programming or F#, but I want to say a few words about F#, because I've used quite a few languages over the years, and I started kind of my functional programming journey in Haskell, which is a wonderful language, and PureScript, which is all fantastic, and Idris, and I've tried all kinds of things. And F# is not the fanciest and most powerful language out there, but it is, in my opinion, one of the best software engineering languages, just to get stuff done. And this is kind of important because it comes with a lot of power, but not too much. It doesn't lure you into doing things that you shouldn't be doing, because in the end, we're trying to produce working features to our users. And many of these fancier functional programming languages, they tend to lure you into doing a lot of stuff where you've been doing category theory for 2 weeks instead of writing features. So F# is really good at this. So if you haven't checked it out, please do. So Oceanbox. We're a small company based up in Tromsø in northern Norway. In 2 weeks, the sun will set, and we will not see it for another 2 months. That's how far up north we are. What we do is we do advanced mathematical models of the sea. So these are sort of digital twins of the oceans with very high resolution. And we make these available to our clients via APIs and our user interfaces. So all the data we have, all the methodology we have is self-service to our clients. And this is a kind of, nobody has really done this before. These are complicated systems to solve, and we have a huge computer in our basement. And currently we have about 18 billion data points in 3 dimensions, where we have about 2 years worth of time series for each of those 18 billion points, which sort of is, we're getting close to 700 terabytes of data archives. And what makes us a little bit special is that everything, pretty much all the code we have, except the oceanographic workhorse, which is an old community Fortran code, everything else we have written is in F#. So we have in excess of 100,000 lines of code in F#, both on the backend side, in pre-production, in post-production, and and all our user interfaces. And all the pictures I'm showing here are actually screen captures directly from our user interface. Everything is written in F#. So let's see. Here's another. I got stuck. Here we go. So here's another example. I just wanted to show this because this is kind of interesting, considering all the talk about climate change. This is a comparison of the temperature in the Arctic Sea north of Tromsø, comparing June 23 and 24, and we had a really warm summer. In at least for us, warm summer. Usually the temperature doesn't go much above 15 degrees, but as you can see, it really reflects in the sea temperatures. So, and I have a final little example of what we're doing. And here's another example, and this is something that our clients can do. They can go into the tool and they can define their own simulations and run trajectories on these oceanographic fields that we have produced, and then they can analyze parasites, viruses. In the future, we are soon going to have oil, other things, and how it will spread and get affected by the sea. So here's an aquaculture site which has gotten some kind of pathogen, and then we can follow it over a period of 2 months and see how it's sort of spreading to the neighboring locations. And we can also pull out time series that shows how the concentration of these parasites will vary in time. So these are the types of things that we sort of work with, just to give you an idea. But when we started OceanBox, we started from scratch. We had nothing, and of course, being serious cloud programmers, we decided that, oh, of course we're going to do microservices. Everybody does microservices. It's the big craze, right? Everybody. If you're going to go do cloud, you're going to be doing it. And we had a complex problem to solve, and we sort of did all the stuff that you do, and figured out what the domains were and how they were related, and sketched up services around these domains. And if nobody has read the book Domain Modeling Made Functional by Scott Blashin, it's a really, really good introduction to F# and to domain-driven design. So I highly, highly recommend that book. So anyway, so we ended up with some specifications. We tried to make them RESTful and decoupled, scalable, and stateless, and all the sort of that we wanted. And then we created 5-6 services and deployed them, and everything looked peachy and nice. But there is a problem. So we started out with having one problem. Now we suddenly had 5 new problems. And people tell you this, but I mean, unless you have been bitten by it, you don't really believe it. But it's hard to deploy and manage microservices. Instead of deploying one service, you're going to have manifests, and there's going to be deployments and secrets and config maps and network policies and so on and so on. Instead of you having them for one app, you have them for 5. And you're going to have to manage this. And in the end, you're going to spend more time managing and hoarding services and trying to figure out why they're not working and what's wrong than you're going to actually spend time coding in the end. So microservices is kind of, there's a bad side to them. So for us, the bottom line has been domain-driven design is great. Microservice architecture, good. Microservices, not much fun. And then I stumbled upon this quite sort of tongue-in-cheek blog post by Scott Blashin again, where he coins this fantastic acronym SPMSA, Single Process Microservice Architecture. And it really struck a chord with me. So I said, perhaps we should just scrap the whole microservice thing, because it's not really giving us anything except headaches. I mean, I don't care if I waste a little bit extra memory and resources scaling the whole app rather than scaling smaller pieces separately. So I looked at this and said, I'll give it a try. Because at the end of the day, we're delivering features, and our customers don't really care about what we write it in and what the architecture is. They don't see it and they don't care. And I found this wonderful little horrible thing, which I thought was a good symbol of microservices. Celery soda sounds wonderfully terrible. I haven't tasted it, but if anybody has, they could please tell me how it is. So to my good fortune, when I decided to go to sort of take our microservice architecture and turn it into monolith, I really like actors. I've been back in the day, I was toying with Smalltalk, which is a wonderful language. I highly recommend playing with it. Really, it's kind of weird, but it's completely actor based. I've been doing a little bit of Erlang back in the day, and I've sort of was thinking about how to design this microservice architecture, and I figured that actors would be a nice way of doing it. So I sort of looked at Orleans and Akka, and then I found Dapr. And once I found Dapr, I scrapped everything else. So Dapr is a really nice tool. I'll talk a little bit about it more in the next slide. But actors, what are actors? Well, actors are essentially objects, but they're separate. They're different from normal objects, because normal objects, you call methods on them and you have state and it's the usual mess. But in actors, you communicate through message passing. Both, in principle, you should do it internally. Most people cheat, but you should always communicate through message passing. Another thing with the actor is that actors, in like normal objects, instead they have identity and they can have state. I say can have state. They don't necessarily have to have it, but they can have a state. And this is kind of nice. So actors themselves, since you pass in a message, there's a little mailbox processor in there. It will receive a message, it will look at the message, and it will do something. And then it will wait for the next message. This means that when you do updates to the actor, it will receive messages in a certain order and will perform them sequentially in that order. So there's no concurrency in an actor. But what you can have is you can have a lot of actors with a lot of different identities, thousands of them, and you can get concurrency in that way. But this is important to keep in mind when working with actors. And for those who are theoretically inclined, it's also a complete model of computation, and there's a whole bunch of interesting theory that you can play around with and learn. So Dapr, why did I go for Dapr? Dapr is a one-stop shop package of libraries for pretty much anything microservices and inter-process communication. And the nice thing compared to a lot of other things like Orleans and Akka is that it's completely language agnostic. You can communicate with the Dapr system over HTTP or gRPC, depending on your performance needs. Dapr implements actors, and they use the Orleans, Microsoft Orleans style virtual actors, which is kind of a nice way of thinking about them and much lower cognitive load than Akka, for example. But Dapr also comes with something called service invocation, which is essentially similar to actors, but without the identity and the state. And service discovery automatically does MTLS, sets up everything for you. So it gives you a very sort of nice way of setting up your software. And it comes with something nice. It comes with unified secrets management. So you can just ask for secrets, and then you can connect it without changing a line of code to different types of secret stores, because managing secrets in Kubernetes and in Vaults and in Azure and wherever is an infinite pain, in my opinion. And the final point here is that when you do Dapr, particularly in the Kubernetes version, it will actually inject a little sidecar onto your pod. And it will do all of it automatically comes with all the observability for the sort of communication between actors and service invocations and so on, pub sub bindings and so on. So you actually kind of get sort of reasonably fine-grained observability completely for free. You don't have to do anything. It just pops out of it. So monolithic microservices with Dapr. So how does this work? I think doing microservices, but putting them into a single process using actors is a sweet spot, because you get strict boundaries. You can't really cheat. You can't just go, I'll just call that thing and skip the actor thing. You have to go through the actor, which means that you keep the strict boundaries. So if you ever need to split it, it's going to be quite easy. Another thing that you get with the actor is that the actor, when it starts up, it spins up, it has its identity. It might have state, which might be persistent, or it might just be ephemeral state, but it will exist for some time that you can configure. 1 second, 60 seconds, an hour, whatever you decide. And that actor, once it's spun up, it's going to be there. And next time a user calls that actor, it will actually remember and say, the actor it's running over in that pod over there. And you kind of get sort of a session affinity. And this is important to us because the data sets that we are dealing with are humongous, and we need to open these big complicated files, and we need to do a lot of random access into them. And there's a good deal of cost opening and closing those archives and computing indices into multi-file archives. So with the actors, we can keep the state between calls. So the user calls in, it will open up the archive, it will find the right files, and it will pull out the data. And the next time the user comes, it's most likely going to be the next sort of time frame, and it already has it open. So it can just return it really quickly. So this is a nice feature of it. I mentioned the observability. Actors are quite performant, and they scale nicely. So you automatically, with the actors, you can just scale your pods horizontally, and your actors will follow. So the way we have done this, and I will show it in this little demo project, is that I started out having 5-6 services. And now in my new monolith, I have taken every single service, which had an actor interface in it already. I tossed out the server part and just kept the actor part and just put it in a separate project. And this is nice because if I ever need to split it, all I have to do is pull that project out, put a ASP.NET server on it, and fire it out. Add the manifests and just deploy it to the Kubernetes server, and it will be running again. And in fact, actually going from a microservice architecture in separate services into a monolithic microservice took me around 2 hours to actually just rewire the whole thing into a monolith. So, and as I said, you can just reverse that process really easily. If you happen to become Google overnight, then you need to scale like crazy. And of course, if you use Dapr, you can just say, if you don't need the stickiness and you don't need sort of the state part of it, then you just can use service invocation instead. So one of the there's a little caveat here if using Dapr Actors with F#, and that's that by default unions don't work well. You end up with a lot of errors. There are ways around it, but you need to you lose a little bit of type safety, and it's not super nice, but it's doable. So I'm going to show you a little demo of how this works. You can find the code for this demo on my GitHub. You see the link down there. It consists of a client, which is of course written in F# using Fable and Lit, which has become my sort of go-to thing to do web stuff. It will just do normal HTTP calls. We use Fable Remoting, which is another wonderful library from Zaid Ayaj, which sort of makes HTTP calls sort of RPC style and type safe. Really nice. On the server side, we're going to be just firing up a normal ASP.NET Core web host, pipeline thing. Add some routing. Then we're going to use giraffe. Register the actors. I'm going to add some extra logging and telemetry and metrics and so on. And that's it. And then I have two microservices that I host on top of this server. They are separate F# projects. One is service A, which implements an actor iActor A, and the other is called service B, and it implements another version of iActor A. So because here's the thing, actors implement an interface, and you can have multiple interfaces, multiple implementations of the same interface. And I'll show you in this example how you can actually use them. And then there's an iActor B in service B. And iActor A will actually call, iActor B on service B will actually call iActor A on service A. So there will be some actor calling actor stuff going on here as well. So let's see how this looks like. Just go to here. And I'm just going to start. I'm just going to start the application. So I hope everybody can see this. So I have a normal .NET run just to run the code. I have to prefix it with Dapr run to run it locally. I say Dapr run app ID dev star app port 8085 .NET run. I get a lot of logs out of Dapr. The thing builds. And soon it should say that it has started. And we can see here's an interesting line, placement table version 101. So this is something that the Dapr runtime figures out where the actors get registered in which pod. And now the web server is running. And we can go back to the web browser and have a look at this. As you'll see, I'm not really much of a web designer. Note the consistent use of fonts, for example. So I have added three groups of buttons. One is called shoot, and I'm not going to talk much about it other than that this is actually using service invocation. So I just added it as a little bonus that you can check out in the example. The thing here is that if I now do reload, so the server is remembering state, I will get a little bit more. Oh yeah, sorry. I changed the name of it. So and call it Monorail. All right, so let's call it Monorail. We'll be happy. So there, the name service lookup or the service discovery failed because I had decided to call it the more Death Star instead in honor of the previous slide. But of course, I had forgotten to change the code that it should call the service Death Star. So now we're back. All right. So now we can do shoot. And the thing is, here the UI is just adding, as I press it, to add shoot, but it sends some messages to the server, which will then do the service invocation. And if I do a reload, it will fetch all the nodes from the server, and it has actually added a target string onto the shoot thing. But let's look at the actors. So here's the actor Darth. That's the actor ID, and I can press that button, and it says, okay, it calls service A, the method foo, and the grain is Darth. Grain is essentially the ID of the little the actor itself with its ID. This in the Orleans parlance, a silo is the pod where it's running, or the service where it's running. So here's the silo is now called Monorail, and it says account 1. So if I press this 2, 3, 4 times, you can see it's storing the state in between me pressing the button. There's a timeout on the actor. So after 60 seconds, it will go to sleep and it will lose all its state because I'm not using the state persistence things. But that's included in Dapr. It's very easy to use, but I just didn't want to have it. And it can store to Redis and to Postgres. I can press actor B, and it says, okay, it calls service B. not service A, but this time it's calling the foo thing on service B. The grain is still Darth, the silo is still on Monorail, and the count is 1 on actor B. And then we can see this actor is calling service A, which is then the other actor, which is still running, and we can see that the count is going up. And then we have this other actor B, which is sharing the state, so that it just keeps growing. And now I can press OB1, and we can see that it starts growing from 1, 2, 3, 4, because this is a different grain. So now I have 2 grains, so 2 separate grains running, and we can add a third. And so this is the application. So one of the things that we can do is that we can go back to here, and I can run the application, the exact same application. The only thing I've changed is now the port from 8085 to 8095. So now I will fire up a new application. It will have a different app ID. So this is different from horizontal scaling. This is emulating actually taking my app and splitting it up again. So now instead of splitting up a little piece of it, I just split up everything into the separate apps. I'll just fire it up. We'll see soon see some notes here that the placement table has been updated. We see also here that something has been deactivated. So you can go see what that was. So now we can see what happens if we press service A. And now we can see that the silo is rebels for actor A. So the runtime just said, okay, just gonna run it there. I have no control over which silo it will run in, but it chose rebels. If I press this one, it also chooses rebels. So we can see, okay. So what about, well, if I go to OB1, it starts putting them on Monorail. So this is essentially what you can do with actors and microservices, and this gives you quite a lot of flexibility. And we have been doing this now for this style for 2 years. First as separate services, and now we have put everything back into a monolith. And life is much better in the monolithic world, I must say. We're spending a lot less time hoarding services and spending time on things that are non-productive, really. And yeah, generally happy. So this was the demo. Let me just go back. I have a final slide on my thing. I was hesitant when I was going to show this slide, but as with everything, I think there's a final lesson here. I try to remind myself every day, don't be too Taliban. So the thing is, it depends. There is no single truth. It's very easy to get excited about some new technology or some new method of doing things, but I've been around for so long that I have learned that, yeah, there is no silver bullet, and so you have to do what's right for the right reason, and sometimes you have to break your own rules when you need to. And the most important thing in all development work is to have good taste. And you see, these are really useful pieces of advice, right? This is stuff you cannot be taught. This is stuff you learn by doing and over and failing a lot. So my second last thing is, don't listen to me, but do listen to Scott Blashin, because he's a Jedi. And go and get his book. It's a wonderful read. And basically, this is all from me. Thank you.
Thank you very much, Jonas. Very nice presentation. I also think you went like the circle from we need microservices to know it's better to be in the monolith, but separated with actors. Exactly.
Yeah.
Be pragmatic. Don't like everything microservices. It will solve everything. Really nice. Question. I mean, when you onboarded new people into your project, has this been easy for them to grasp getting into this?
So we're currently only 2 people, I think, working on this part of the code. So yeah.
Got it.
So I think there might be a little bit of I mean the all is not actors can get a little bit, it can get confusing, and when you suddenly have stuff not working, it can be kind of hard. So that I need to say, it can be hard to understand what's going wrong. But all in all, in general, actually, there was one thing I forgot to show you. So let me just jump back very, very quickly, and open up a new tab, because all the time here. So I have a LGTM container running locally on my machine, and all the time I just set up everything, all the logging going to this container, and now I can just go to explore. I choose the Loki, and I select certain, and I default, and I do run, and then we can see all the stuff that was going on here. So here we can see the logs that were produced, and I can, let me see if I can get this somehow up. Oh, I think I might need to go a little bit smaller. Right, so we can see here we get the logs, and now I can just press on any of these. I can see all kinds of information, but one of the nice things is also get the traces. And here I can actually see what's going on with Dapr. And I haven't instrumented anything, and this is a monolith, but I actually get quite detailed information about what's going on inside the application, which actors get called and how long the things are taking. And you can see it's not really a lot. I mean, it's a few milliseconds.
Yeah.
So
yeah, that's really useful, especially when you debug stuff or you just want to understand what's going on in the application.
Yeah. So this is really great stuff, I think.
Yes. Yeah. I mean, I started my career working with C, and then we had to write log. And then
yeah, me too.
To a text file, and where is it? What's going on? Huge difference with Grafana and this. Huge difference. Checking there's like people are like giving you claps in the chat. Yes. Well, thank you again, Jonas, and thank you very much for your very nice presentation. We'll put out links to everything afterwards, so people can find all the Dapr libraries and etc. I guess people are very interested in that. Yep. Thank you very much, Jonas, and thank you for your nice presentation. Welcome.
I have to run to my next meeting. So start up life.
Yes. Cheers.
Cheers.
With that, thank you very much, everyone, and I hope you enjoyed both of the presentations. We'll be back in December, so make sure to stay tuned. And to wherever you are, good morning, good evening, good afternoon, have a nice day, and until next time, bye. Bye for now.